Hi, I'm Ed Freeman, and I've been doing data science since about the mid-90s. Now that's way before the term data science got invented, but the field has had a lot of names. Data science, data mining, machine learning, knowledge discovery in databases. The thing is, the principles, the fundamentals don't change. And that's the kind of stuff that I'm talking about, the stuff that doesn't change even as the name changes. The fundamentals of actually doing successful data science projects. Now today I want to talk about applications. Here's the key. Data science models have absolutely no value to an organization. It's the applications that are driven by the models that have the huge value. Now, I'm talking about the application, not just the software app, but really how it gets used. You have to understand how people are going to use, and there's a kind of a trap here called automation bias. What that is, if I give somebody a score, they're going to assume that the machine is right and they're wrong, and that's something to get away from it. And this is, if we look at stories about how things get used, oftentimes stuff is sold as being, oh, here's this perfect score, blah, blah, doesn't work, blah, blah. Oh, you're supposed to have human in the loop. It takes a lot of stuff to get that right human in the loop. There are a lot of privacy, ethics, and fairness concerns. There's one thing I want to bring up here is the Pennsylvania Child Welfare Organization was working with a machine learning model to detect abuse and abuse probability. Well, again, you've got a big automation bias here that if the machine says something, it's going to be very difficult for a person to actually fight against that. And the thing is, they found that there was a huge racial bias to their scores. And as data scientists, we have to care a whole lot about this. We have to be proactive. Even if our client isn't talking about this, we have to. And there's only one thing to do about this, and that's be completely transparent about how the scores get generated. Companies hate this, but we have to get over this. It's, yes, you have a lot of intellectual property in the score, but as a customer, if somebody isn't transparent about how it's generated, don't use it. Every single time I've ever heard the term, I don't understand this, but the model must be right, the model has been wrong. I want to talk here about a particular model, Toronto beach safety testing. They have a lot of pollution. They want to know when it's safe for people to go to the beaches. What they were doing is testing every day, which is not bad. They put in a machine learning application that said it was 90% accurate. Well, first off, 90% accurate sends a lot of red flags to me as what accuracy do you get if you say there's no problems? And as it turns out, there are a lot of problems. They simply got stuff wrong. They were simply sending people to the beach when it was not safe. You have to understand how the whole thing gets used. Now, there's a good book here I want to reference that I've been getting a lot of value out of called Project Ecology by Eleanor Piper. The idea is that I've got a project. It exists in an ecology that uses the results of the project, not just for software and machine learning, but for everything. And I'm finding it incredibly valuable. Now, here's the thing. I want to expand about what Toronto is doing. Training and tests don't count. People in the machine learning data science community care a lot about bias versus variation. They don't matter. What actually matters, how a model and application earns its money, is on data that doesn't exist and is actually data in deployment. Now, training and test data are just a way of estimating this. And I want to get into Toronto again. They had a 90% accuracy. Well, you gotta sweat bullets about looking what that 90% accuracy gets to. Like, what kind of mistakes is it making? Can you live with those mistakes? If not, accuracy doesn't matter. Now, here's something. It's also expanding on this. Don't get too tied up in model optimization, because you're optimizing on data that doesn't matter. Get something that's good enough to try out. And now there's a last thing. Even if I can put data together, I have to be able to conceptually understand the data and how it's being processed to make sure that it's stable, to believe that it's stable. Now, I can't guarantee that it's stable. It will eventually be unstable. Like the 2008 mortgage crash is a great example of stable data becoming rather abruptly unstable, catastrophically so. We often say in deep learning that you can't understand what's going on. That's not good enough. You have to be able to believe that this thing you've got on the training and test data is going to work when you actually roll it out to real customers. Now, the last thing I want to talk about here is the new stuff. Really amazing stuff coming out with GPT-3 for text, DALL-E, and others around images. They're really creating a new branch of applied data science. And it's also creating new ethics concerns. Like with DALL-E especially. There was no permission given for art to be used, which is really disturbing. This whole branch is dependent on people being powerless to enforce their own rights, which is, God, that's icky. There's also, I want to go into Galactica from Meta, that it was supposed to basically produce research articles, and it gave wrong answers. So you've got this whole ethical thing of rolling out this thing that does wrong answers. Now, Galactica fortunately made obviously wrong answers. What happens if they're subtly wrong, but occasionally, 1 in 1,000, disastrously wrong? Kind of accuracy doesn't matter here. Now, the thing is, what I'm getting to, we've got this new branch of applied data science. Nothing here I've said changes. You got to care about the whole application. How do people actually use this stuff? And lastly, you're going to have to unite both business understanding and technical knowledge. How do the techniques and the business mesh together? You can't have the two siloed. Well, that's it for today. And this gets into what I was talking about earlier about Crisp++. If I've got a data science project, all things interact, and so you've got to be able to have some understanding of all things. Every person understands the whole. So, and I'll keep on going this. And well, that's it for today. Talk to you later. Bye.